All right, welcome to 1.8 exponents in order of operations. We've done a little bit with order of operations so far. We've mentioned exponents in terms of like terms. We wanted to have exactly matching variables, exactly matching exponents. Now we're going to look at what that means a little bit more closely. The other thing I try to do is I always try to kind of highlight and give you a fair warning that we're nearing the end of well, we're not nearing, but this is the end of the material that's going to be covered in the next exam. So exam 1 is covering chapter 1, which is sections 1.1 through 1.8. Remember, we've been talking about this. This is a no calculator exam. So you want to be practicing without a calculator when you're doing your assignments and doing your practice problems and working the problems in class too. Get yourself really ready for that. So let's talk about exponents, and usually if you've kind of seen the trend in my notes, I usually do some of my own explanations and then some examples, and then I follow up with what the book has. But when I teach exponents, I feel like the most helpful thing is to really come back to the definition of what an exponent means. If you can keep a handle on this, it'll keep you from making typically the mistakes that I see students make when they're first working with exponents. Okay, it's one of those things that you have to get used to because it's a new notation. Math is a language, so we need to get used to the symbols and the markings and what they mean, and then operate accordingly. So exponent is a way to talk about repeated multiplication. Well, what does that mean? Well, let's back up and let's talk about what multiplication is first of all. Multiplication, one way to think of it, is the fact that it's repeated addition. What do I mean by that? Well, if I were to add 3 plus 3 plus 3 plus 3, 4 different 3's together, our answer would be 12. Multiplication is a way to tighten up the notation, to use up less paper space, less symbols here to mean the same thing. So multiplication would be written as 4 times 3. Or you could write it with the little dot or the X, but 4 times 3. It's a different operation that's being used here. It's a new operation that does the same thing. It causes the same result. We wouldn't look at 4 times 3. We're so used to seeing multiplication now that we wouldn't be tempted to say, well, 4 plus 3. Even though multiplication is repeated addition, you don't look at the symbols and say, oh, well, I add here, right? We've learned to multiply. That's the same kind of thing you want to do with exponents, because exponents are repeated multiplication. So if I have 5 times itself, 5 times 5 times 5 times 5 times 5 times 5, okay? That is repeated multiplication, just like we had repeated addition up here. And we found a way to write that in a more succinct way. A new operation, multiplication. It's repeated addition. Same thing. Now we have repeated multiplication, 5 times 5 times 5 times 5 times 5 times 5. And now exponents allow us to write that in a more succinct way, simplified, smaller version, less paper, and we can see at a glance what we're doing with that multiplication. And what that would look like is 5 to the 6th power, 5 raised to the 6th. 5 would be the base that you're multiplying, 6 would be the exponent. And we wouldn't say that's 5 times 6, just like we wouldn't say, so let's pull that over here for a second here. Let's take that 5 times 5 times 5 times 5 times 5 times 5. 5 times itself 6 times. And you end up with that 5 to the 6th. Okay? This is a different operation. Just like you wouldn't say 4 plus 3 gives us the answer of 3 plus 3 plus 3 plus 3. You expect 12 here. 4 times 3 is 12. We would not say this is not equal to 5 times 6, okay? It's 5 times itself 6 different times, okay? okay? 5 is going to be your base. Okay, the exponent there in this case is 6, so 6 is the exponent. And you have a repeated multiplication, 5 to the 6th. Okay, let's use an example where we might know the numbers off the top of our head. These are a little bigger for a no calculator situation. Let's say we had, what would be a good example here? Let's go, let's go 5 cubed. Let's just narrow it down a little bit. Let's say 5 times 5 times 5. In exponent form, that's 5 to the 3rd power. 5 multiplied by itself 3 times. Order of operations would tell us that 5 times 5 is 25, and then 25 times another 5 is 125. So, and that's what 5 to the 3rd power means, 125. It does not mean 5 times 3 or 15. Okay, you want to resist that urge. You do not multiply the exponent times the base. Okay, so when you are in a test situation and you're wondering, wait a minute, what do I do here again? Fall back on the definition. This is one of the best things you can do for yourself with exponents. Other thing I want to highlight right from the beginning is what happens if you have b, just plain old b to the 1st power. It's just b. Okay, so or any number, any letter raised to the 1st power is the same as just that letter that we see. And we've been talking about this already when we talked about like terms. And we said they have to have exactly matching variables with exactly matching exponents. Sorry, slipping away here. Exactly matching variables with exactly matching exponents. Some of the examples we had were just plain variables. They didn't have an exponent that we could see. For example, like 3b and 4b. Those are like terms. The reason why they're like terms is because not only the b matches in each one, but the exponent matches too because of this. B to the 1st is just the same as b. Okay? Now, we'll go through this a little bit more detailed later, and we really look at it in Math 65. But if you can't wait, come talk to me. I can also hook you up with some online resources to look at this, but I can also talk you through it too. It then sometimes leads to the question of, well, what does b to the 0 equal? And I'd love to have that conversation with you, okay? That's a later topic, but I'd be happy to do that with you early, okay? So let's look at what we're going to do just in terms of the numbers first. We're always starting out with the numbers. We'll add the variables later. The instructions say to evaluate each exponential expression. So the expression tells us there's no equal sign. Exponential, no surprise here, we're going to involve exponents, okay, in these problems. And evaluate. Evaluate means that we are going to find the value. You see that root word in there, value. That means we're going to find the value of what we're given. We're going to work out the operations that they tell us. So let's start with 6 to the 3rd power, or 6 cubed. By definition, okay, so always come back to the definition of what an exponent is, because this does not mean 6 times 3. Okay, this means 6 times itself 3 times. And working that out using order of operations, multiply the 1st, you just go left to right, multiplying and dividing, so 6 times 6 is 36. Then you still have the 3rd times 6. And then 36 times 6, if you have to, do it out to the side by hand. 36, carry the 3, 18 add the 3 is 21. That should equal 216. So 6 cubed is a far cry from 6 times 3. 6 times 3 is only 18. 6 cubed is a much more powerful answer. You see why we call it powers, okay? It really multiplies that number quickly. It raises up that value in a hurry. Okay? So that's what it would look like to raise something to the 3rd power. What about raising something that's negative to a power? Okay, so watch number 6 here. What's different? Well, I've got parentheses, I've got negatives. Is that going to change how I do this problem? No, no, no. I just take what I'm given. The base is everything that's inside the exponent, so by definition, this is whatever's in that parentheses times itself, okay? So by definition, it's whatever's inside that parentheses times itself. Well, what's inside? What's inside is a negative 10, so I multiply negative 10 times negative 10. I rely on our 1.7 information, which taught us that a negative times a negative is equal to a positive, because they're the same sign, so you're going to get a positive answer here. So that means I'm going to get a positive 10 times 10, which is 100. Okay. Now, the try problem that I'm going to leave you to do kind of combines both worlds here. You've got a negative 10 raised to a third power. Well, we've practiced to a third power, and we've practiced having a negative 10 involved. So you combine those skills and try negative 10 to the third. Hit the pause button, come back and check it. Okay, for number 8, you should have gotten negative 1,000. All right, we'll see you at the bottom of page 1 for more examples.